Hi there, I'm Scott Johnson. I'm here to talk to you about AWS Security 101. All right, so here's what we're going to talk about. I'm going to go over who I am, give an introduction. I'm going to talk about a couple of security basics you should keep in mind. I'm going to talk about AWS security specifics. I will cover an actual security breach. If there's time, okay. All right. So the first thing we're going to start with is an introduction. So my name's Scott Johnson. I'm a full stack developer. I'm an architect. I write code for a living each and every day. I work mostly in Ruby. I work in Rails. I do a lot of, these days I'm doing a lot of Python. I use Ansible for DevOps. AWS is my cloud provider of choice. A little bit of Elixir around the edges. Wish I could do more. And a bunch of machine learning as of late. I am currently a full-time consultant to the ADL, working on working on monitoring and detecting hate speech. I have been using AWS since S3's launch, which puts me among one of the older users, because S3 was the first thing they shipped. I have more slides than I'll have time. The rest of it's on YouTube, and the link is there. Just look for today's post. Okay. I don't make a lot of videos, so it should be relatively easy to find. And I'm sure this thing will end up on YouTube also, but it won't have the slides that I don't have time to present. And the final thing is, can someone tell me when 20 minutes pass? Because the case study takes 7 or 8 minutes. It'll take me a minute or two to wrap up wherever I currently am. And I want to leave time for that because that's actually pretty interesting. Or I found it interesting and I lived through it. All right. So a couple of security basics to keep in mind with AWS. The first thing to keep in mind is that AWS is locked down by default. Okay, it operates basically pretty much by least permissions to most permissions. There's one exception to that I'll talk about when it comes to access keys. So to some extent, what you mostly have to do with AWS in terms of security is don't mess this up. All right. So now here's the honest reality. In terms of what I'm covering, the cloud is mostly just hosted Linux boxes. So the corollary to this is securing the cloud is just securing Linux boxes. And that sounds great, except then you realize that every security breach that affects Linux affects the cloud. And oh yes, that includes the one that was announced yesterday about sudo -1. Most of what I'm talking about here basically falls into an AWS context referred to as EC2, basically computers in the cloud. I'm not here to talk about serverless and security. I'm not here to talk about Kubernetes and security. I'm not here to talk about Fargate, etc. Like, there's lots of ways in which you do security on AWS. This is the basics, okay? And I sort of look at AWS as you have to master the basics of computing in the cloud, which means EC2 and instances. All right, so now we're going to talk about AWS security specifics. And we're going to start with the words. We're going to play word soup. So when it comes to security, you've got things like EC2 and IAM and security group, API key, PEM file, VPC, VPN, CLOUDTRAIL, etc. All right, so we'll start with the basics. Computers in the cloud. EC2. So just think of an instance as a virtual computer in the cloud. Think of it as a server that once upon a time would have been rack-based and now probably is not actually rack-based, or it kind of is, but who the hell knows what actually AWS has got going on in their data center. Personally, I often think they simply have yoked Cthulhu and they use it for compute processes. And all of our cloud stuff is being driven by the elder gods. That's kind of the metaphor I like to think of visually when I think of an AWS data center. And God knows there's enough cabling in there, right? It could all be tentacles. All right. So when you deal with instances, security groups are your key thing. Okay. And then the other key thing is your IAM role. And the final key thing is a little checkbox that you will see when you create an instance manually that says Enable CloudWatch Detailed Monitoring. And we're going to come back to that. All right. And when you go through the instance creation process, these two things are really important, right? Picking the IAM role and turning on Enable CloudWatch Detailed Monitoring. Those are your two classic security mistakes with EC2. The next thing to keep in mind is that most EC2 stuff is by default on shared tenancy. And what that means is someone else is using the box at the same time as you, and if they are tricky enough or you are paranoid enough, this should be of concern to you. Okay? Because theoretically, memory can be poked at, it can be monitored, etc. So if what you've got is really, really sensitive, you always have the option of dedicated tenancy, right? It's a lot more expensive, but it is definitely an option. And if for certain purposes, it might actually be appropriate, such as, for example, if you're building a box that processes credit cards. Okay, now, hopefully you're not building a box that processes credit cards, and hopefully you're using that through Stripe or somebody else, but it still happens. All right. IAM. IAM stands for Identity and Access Management, and it's basically the AWS user architecture. And underlying all security architectures is always users, and passwords are kind of not passwords. Like, passwords are still a thing, but it's not really passwords, because really what you care about with IAM is the access keys you're generating, but we'll come back to access keys. So when you create a new AWS account, the first thing you've got and the only thing you've got is what's called the root user. And then below that, there are role-based users. So you could, for example, have your EC2 user, right, which have a set of permissions that are different from the root user. The root user can do anything, and as such, you probably don't want to have the root user doing stuff. So you want permission-limited users tied to the role. So this might be, for example, think of this in terms of your application. So it might be that you have a role-based user for my web front end, okay? And then this has a certain set of permissions that, for example, might not include the creation of EC2 instances, okay? And then your deployment engine, which actually creates the EC2 instances, might have a different role-based user. Just simple. Never use the root user for anything. Okay, it's a bad idea. All right, and now the next thing I should tell you is I do not claim to be an expert in IAM. I wish I was. I probably should be. Certainly, after having given this talk, I feel very, very decently shamed in becoming a root user, becoming an IAM expert. All right, so we're going to walk through the UI on this. So it starts off when you go into IAM with giving you with listing the roles you've got, and then giving you the ability to create a role. You will always see the roles that you have when you create a role, and these are the default roles that you've got. Okay, I have not created a single role on this account, and so I know that these roles actually exist. When you create a role, you give it a series of services that are going to use it. Okay, so if this was a deployment system, it would have a role like create an EC2 instance, because that's what a deployment engine does. Okay, and it would not necessarily need the ability to transcode videos or do elastic load balancing, etc. Okay, so you can lock this down very much. Roles get permissions. So in this case, I've got roles get permissions, and those permissions can do things like administer the gateways or etc. Okay, and permissions can have boundaries to define the maximum permissions. Okay. Now, these permissions are nothing but JSON. Okay, and if we jump ahead to the next slide, you'll see that. Now, the nice thing about this is that JSON is very easily manipulated by a deployment engine, so whether that's AWS, whether that's Ansible or CloudFormation or SaltStack or something else. Okay, so you can use this as a way to generate permissions dynamically when you create stuff. IAM users can have tags. Tags can be IAM users can be right down to actual representations of the physical users. Okay, they can include things like an email address to identify them, a role, etc. Once you're done creating your IAM, you get a chance to review it. Okay, now this is like any other role-based security system. It's hard to get right, and you're going to iterate on it. Okay, and the way to deal with this is just accept that and do it. All right. Security groups. Next really important thing. Okay. Security groups are nothing more than firewalls. They are a set of permissions like allow traffic in on 80 and 443 and allow traffic out on 3290. Okay? You want to use multiple security groups, right? Because when you use multiple security groups, they become composable and you don't have to create them multiple times with lots of complicated permutations. You simply assign, okay, this box, I need SSH in, I need HTTP, I need access to web, or access to RDS, and I don't need anything else. They filter traffic in and out, they're a firewall. And there's a web-based interface to create them. So the first thing to understand is when you're creating a security group, it always starts with SSH. Okay, this is useful if you want to allow SSH in on a box, and it is not useful if you don't. So you can make this decision very deliberately. Okay, right, and you can also set things up with essentially a bastion host, whereby people SSH into one box that has the outside world exposed, and then they SSH internally throughout from box to box, so that you don't actually directly allow an outside SSH in. Okay. Amazon does a fairly nice job of supporting all the different protocols and giving you a quick down, so you don't have to know, for example, that 443 is HTTPS and so on. Make the name good. Okay, this is going to pay off in the long run. Okay, now I would actually argue that I named this poorly here. Both to force the explanation, but also to illustrate the composability, right? Like, I should have had one security group for SSH and one security group for HTTPS, okay? Or have one based on a functional level, like this is the security group for a web server, okay? However you want to do it. So name these well. The default name, which basically is Launch Wizard 1, Launch Wizard 2, Launch Wizard 3. Default name sucks. Okay. The next thing to understand is that you can rename these after the fact because these are attached internally by their object identifier, not by their name. So it's got an object identifier like SG3467A, and changing the name does not affect that. And you will have a lot of these over time. Okay? So try and make them good. API keys. API keys are really, really, really important. Okay, because API keys allow your machine to do other things. Okay, and they give highly granular permissions. So it's a set of credentials. Basically, think of it as a username and password for a machine to use other machines. It's just an ASCII file with a bunch of values. And those are usually set as environment variables. Okay, and what you want to do is rotate these regularly. Okay, and you need to build your security tooling and your DevOps stuff around the ability to do this. PEM files, these are fairly minor things that are used for SSH into a box. They are created at EC2 instance creation, and they're not recreatable. You lose them and you're kind of hosed. Okay, VPC, and we're now sort of moving through the terms. VPC is short for Virtual Private Cloud. Basically, this is a virtual network that is dedicated to your Amazon account, your AWS account, and it's logically isolated from other virtual networks in the AWS cloud. So basically, it's a way to group all of your network crap together, okay? And ensure that packets don't go where they're not supposed to go. Now, one of the things that we all assume, because Amazon gives us a VPC when we start, we all assume that there's one VPC. That's actually not true. You can have as many as you want to some extent, and you might want to consider a VPC per section of your company or even per project, right? Because they give logical isolation, and logical isolation is a really good thing. So I have been doing computing for a long time, and I never really understood VPNs until just recently. Okay, like I know technically what they are, right? They're a virtual private network. Okay? and they give a way to manage your traffic, etc. So, but whenever I bring this up to an IT guy, and I'm a software developer, I'm not an IT guy. The IT guy says, VPNs make us secure. Ho ho. And I'm a developer, so I think SSL makes us secure. And, well, of course, then we look at the code base for SSL, and that gives us a bit of a anyway. But both of these are actually true. And one of the things about VPN is a VPN gives IT an easy way to turn off a user, because you simply disable their VPN access, and if the VPN is the choke point on all traffic coming into the system, you don't have to worry about deleting 500 accounts across 500 different servers. You just delete the VPN. This is a huge win. And I am actually a case point as to why you want this. Because when I left my most recent full-time gig, which I left a couple months ago, I was a senior software engineer. I had been responsible for deployment, and I had access to every single credential that company had. All right, so the next thing up that's important on security is what's called CloudTrail. And CloudTrail is actually pretty important, and I'm going to give you the official AWS definition. AWS CloudTrail is a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. With CloudTrail, you can log, continuously monitor, and retain account activity related to actions across your AWS infrastructure. CloudTrail provides event history of your AWS account activity, including actions taken through the management console, SDKs, command line tools, and other AWS services. This event history simplifies security analysis, resource change tracking, and troubleshooting. And that is a heck of a mouthful. And here is my rebuttal. No. Okay? Because what CloudTrail is CloudTrail logs everything. Okay? And I can tell you, having suffered through breach events, that there's stuff that you can't find in CloudTrail. Now, I don't know if CloudTrail actually drops events, or if it's that we didn't have certain options checked off on instance creation. But as far as I'm concerned, CloudTrail ought to be there by default. It should not be an option. Okay? If it's this damn important, you shouldn't be able to get around it. But apparently you can, or there are bugs in it. So when we look at the CloudTrail UI, the first thing that comes up is it gives you recent events. So you can see, for example, yesterday I deleted old access keys. I created new access keys 2 seconds later. I also used the detect sentiment action. You can drill down and look at any one of these. You can actually search across this. I have not found search to be massively useful. Possible there was some user error there. And then you can even go down to the level of creating a very specific trail. Okay, so you can say, I want to have a trail created for this region and force everything here for an audit purpose, perhaps. Okay. All right. And now we talked about AWS security specifics, and now I'm going to give a security breach case study. So the first thing to note, this happened about a year ago. And yes, of course, it happened on a Saturday. It always happens on a damn weekend. And you think this is unfair, and it is, but the reason that these things always happen on weekends is because weekends are when people aren't watching. Okay? So we saw in one day, our bill went from $11,000 for the month to $25,000 plus that day. Okay, so we had a $14,000 plus event in a single day. Amazon, interestingly enough, did not shut down our account. Okay, I would have thought they would have, but apparently that was not enough of a bursty traffic pattern to do that. And what happened was our API keys had unlimited permissions, and they were used, or at least unlimited permissions for instance creation, and they were used to launch Bitcoin mining on GPU boxes. Okay, so somebody made a bunch of money, or at least some money, that day using stolen resources. So the first thing we have to deal with whenever you've got a breach is not solving it long term, but dealing with it right away. So what did we do? First thing we did was we deleted our damn access keys. Okay, and what that did was that stopped new abuse coming in. Okay, so no one was able to launch another new machine using this, because these are some big ass GPU boxes. Then what we did was we shut down every existing box using the console, and then we watched, because there's latency involved in all this stuff, and you will not see in the console necessarily that a box is in the process of coming up. You should, but you don't always see it. Okay, the AWS UI is a funky beast. And so we monitored that, and we spent like a half an hour to make sure there was no more boxes coming in, because they kept coming in for a while. We then created new access keys, and we took the appropriate steps in our deployment system, which amounted to, we created the access keys. We encrypted the access key. We copied their values down to our local system. We encrypted them using Ansible Vault, pushed them up to our deployment engine, and then did the deploy. And then we did the next step, which was we rebuilt our keys with limits, better limits. And then we deployed again. And when you have one of these things going on, you will very quickly find out the limits or benefits to your deployment system. I wrote a deployment system, so there were both some benefits and some limits. And the final step is we did a postmortem. Okay? That last step might actually be the most important one. All right, so what did we learn here? First thing we learned is be scared of consulting firms. Now, I say this with some degree of honesty because I actually am a consultant. All right, and there are good consultants and bad consultants out there, as there is good and bad in the universe. And the good people that put this on, they do consulting right, and this isn't an issue. So what we found out when we dug into this was that any employee who had ever worked at that firm had access to all of our boxes and all of our security keys. That mildly effing terrifying. We also were able to audit the key that was used for this and discover when it was created, the fact that it was no longer a current key, and the key link came from them, not us. So the rule of thumb I always use is when you get code from a consulting company, you do a security audit. Okay? And you do this even if you just spend a bunch of money with with the consulting firm, even if you spend money with somebody else to get the security audit done, you still do it. Something about foxes and hen houses, right? All right. So what else did we learn? GitHub repos are constantly monitored for keys by bad actors. In this case, our consulting firm let something out into the public that shouldn't be. The key was scooped up by an automated monitoring bot, and then I don't know if it was sold on the illicit market or just used or what, but okay. But any of the big source code repositories, GitHub, Mercurial, Bitbucket, they are all constantly being monitored for keys by bad actors. This is actually a very real thing that happens. And I used to be a bit of a security denier, saying that things weren't actually that bad. Nope, things are that bad. Next thing to point out is that gitignore is your friend. Use gitignore to prevent things like security credentials from going into your repo. Because once something goes into your repo, it is very, very hard to get it out. Okay? Because someone can always troll back through the history. All right. If you're not using .git/hook/precommit, you are probably making a mistake. Preventing bad code from going into a repo is better than trying to fix it later. And even for personal projects, I actually use this. Bunch of blog posts up there if anyone wants to see. And the final thing is if you're using a deployment engine, whether it's Ansible or SaltStack or Puppet or Chef, don't use Puppet or Chef, always encrypt your keys. Okay, most of them have runtime encryption facilities. What else did we learn? And this is the business stuff, and this may actually be a bit more important. AWS is slow to refund your money, right? That bill that you're going to incur on, say, August 18th, that's going to spike your bill up by 14 grand, you're going to actually end up paying that bill, okay? And Amazon is not going to refund your money until they've assured themselves that this wasn't actually you, and they're going to sit on that money for a month or two. Sorry. Now, thankfully, we were a big enough business that it didn't matter to us, but in a small startup, that could be a big deal. And the next thing is AWS takes this crap seriously. They are not going to refund you twice. So don't screw it up a second time. And the next thing is, remember that magical CLOUDTRAIL, if you don't set it up right, it is not going to be as useful as you think it should be. And I have seen multiple occasions where I have tried, where myself and other pretty serious tech folks have tried to find stuff in CLOUDTRAIL. I'm not entirely convinced that it was entirely us. All right, what else did we learn? Do the damn postmortem, okay? All right. So your postmortem basically boils down to asking yourself two questions. How the frick did this happen? Okay, and you really want to understand this. And the best time to do a postmortem, honestly, is right after it happened, when you're still tired from dealing with it, because that's the point when you're most likely to be intellectually honest and admit your failings, because at that point your pride's been beat up already. And then, how do we keep it from happening again? And then you want to teach this internally. I am so sorry. Thank you. Slides are up on my blog, and enjoy.